Assalamualaikum warahmatullahi wabarakatuh. We are from Group 2. We present our mini project which is about the first law of thermodynamics in grid. Our group consists of Nurul, Amila, Diyanah binti Kamarul Bharin, KH22008, Noor binti Jafarulla, KH22013, Siti, Farah, Erdina binti Noor, Azam, KH22019, and lastly, Nurul, Syafinaz binti Zaharul, KH22022. The table of contents of our presentation today is, first of all, we will explain about project summary, introduction, problem statement, objective, flowchart, programming using MATLAB, program output, result, discussion, and lastly is conclusion and recommendation. Okay, next, I will explain about our project summary. For your information, graphical user interface, as known as GUIs, simplify how we interact with computer programs. It uses easy to understand visual elements like buttons and icons, making it simple to control software by clicking and pointing. In the context of the first law of thermodynamics in our GUI, user can explore isochoric, isobaric, and isothermal process. This helps users grasp the fundamental of energy conservation in this process. Our GUIs also enable users to see graphical representation, aiding in understand the distinction between each type of process. For calculation, user can input pressure in kilopascals and volume 1 and volume 2 in cubic meter to compute work for isochoric and isothermal process. In the case of an isobaric process, where pressure remains constant, the work is zero. Additionally, our GUI allows user to convert volume between liters, dm cubic, centimeter cubic, to meter cubic, as well as convert pressure units from bars, psi, or torr to pascal. Next, we move to the next part, which is introduction. From first law of thermodynamics, there are three phases, which is isochoric, isobaric, and isothermal. By using our GUI, the user can know the definition and the graph for each process. Not only that, the user also can calculate the value work for isochoric and isothermal process. Put the value of pressure in pascal, volume 1 and volume 2 in meter cubic. Not only that, the user also can make a unit conversion for volume and pressure. For volume, the user can make a unit conversion from unit liter, centimeter cubic, diameter cubic to meter cubic. Meanwhile, for pressure, the user can make a unit conversion from unit bar, psi, and torr to pascal. MATLAB message box function serves to create a message dialog box, adjusting the message to fit a proportional figure size. By using this function, we can explain each aspect of the first law of thermodynamics, giving users a contextual understanding. For instance, isochoric refers to a thermodynamic process at constant volume, similar to isobaric, which involve constant pressure. Lastly, an isothermal process maintains constant temperature, ensuring thermal equilibrium during gradual heat transfer. In MATLAB, switch cases evaluate an expression, allowing specific statement to execute based on the outcome. The plot function, taking x and y value, enables the graphical representation of various processes. Combining this function aids user in visual understanding the distinction between processes. Work calculation involves the input function processing data for isochoric and isothermal processes. This function, along with if-else command, streamlines the calculation process based on thermodynamic principle. The work equation relates to the product of pressure and volume change. For unit conversion, user can convert volume and pressure using functions like menu, from, input, and else if. This ensures a seamless and versatile experience for users engaged in unit conversion, accommodating various input formats for volume and pressure.
The first problem statement is difficult to calculate work for first law of thermodynamics, especially isothermal and isochoric. Many students face the difficult to calculate the work of first law of thermodynamics because they were not having a strong concept and understanding in the beginning to learning this topic. It makes the calculation result become wrong or incorrect result. When there are many units conversion before insert the value of volume and pressure in the work equation, it can make many students to do mistake in the calculation during this time. The last point is lack of time. The complex calculation manually of work with different unit conversion in a short time can make many students to do careless. Also, this problem affect the performance of the student during learning this topic. The first objective is to determine the volume of work in joule for isochoric and isothermal. The next one is to determine the unit conversion of various scales to SI unit, such as volume must be in meter cubic, and pressure must be in Pascal. The last one is fast and reliable. It is to develop an easier way for students to calculate the work for isochoric and isothermal in a short time with accurate result. Main flowchart. Firstly, guide home. Secondly, definition of the thermodynamic process and graph of the thermodynamics will be shown for isochoric, isobaric, and isothermal. Thirdly, unit conversion for volume in meter cubic and pressure in Pascal will be shown. Lastly, this program will calculate the work in joule for isothermal and isobaric. So I will continue to the next part, which is flowchart for definition. We beginning with start. Next, push button process. There are three process options, which is isochoric, isobaric, isothermal. Each process they have their own definition. If we choose one of the process, the definition will be shown in a text box. This is the end of the definition flowchart. Next, we will go into the flowchart for graph. For graph, we using the switch case program, which is for isochoric, isobaric, isothermal. Case 1 for isochoric, case 2 for isobaric, case 3 for isothermal. Each cases have their own graph. If you choose one of the cases, the graph will be shown as the output of the each of the process. Unit conversion for volume and pressure are using switch case program. So I will go through with unit conversion for volume first. There are three options we can use, which is liter, BMQ, centimeter cube. We can convert these three into meter cube. And first, you choose one of them, then enter the value. If volume equal to 1, it will proceed for converted liter into meter cube. If volume equal to 2, it will proceed convert BMQ into centimeter cube. Then volume equal to 3, it will convert the centimeter cube into meter cube. Value for volume in meter cube will be shown as the output. This is the end of the volume unit conversion. Next, for the unit conversion for pressure, we are using three options, which is bar, PSI, torr. These three options, you must choose one of them. Enter the pressure value for pressure. If the pressure equal to 1, the bar will be converted into Pascal. If pressure equal to 2, the PSI will convert into Pascal. If pressure equal to 3, torr will be converted into Pascal. This program we are using switch case program. There are two options, which is isochoric and isobaric. We must enter the value for V1, V2, and P. V1 and V2 must be in unit meter cubic and P must be in unit Pascal. If it is for isochoric, we can proceed with process equal to 1 and work will be calculated. Or if it is for isobaric, we can proceed with process equal to 2 and the work can be calculated too. The work value will be shown as the output.
Okay, next, for detail program and program output. There are four program output that we use in this program, which first, selection function, and second, formatted output, third, repetition and mathematical solving function, and lastly, user input. For first, selection function, this function enables the user to select and choose the graph that they want. This function will pop up the image of the pressure against volume graph. Second, for formatted output, we use the message box to give the definition of each of thermodynamics process. Third, we use the repetition function and mathematical solving function. There are commands that helps user to calculate the works from the equation of work equal to pressure times with volume 2 minus volume 1
Then the user can calculate again by press the reset button. Lastly, the user input. User can key in any value of volume 1, volume 2 or the pressure to get the works answer, or user can convert the unit volume or pressure by keying the unit and they can get a new value unit. So next, we will see our result.
Okay, so here we can see the result for our GUI. And now we are going to look into the first section. So here is the definition for thermodynamic process, where we use the function of push button. So in push button, we already set message box for the definition to appear. So for example, if you click on isocoric, then you can see there's a definition pop out. Same goes to isobaric and also isothermal. Okay, then we go to the next section for graph of thermodynamic process. So here we are using switch keys by inserting it in pop-up menu. So we have several choices here. Now you can pick one and the graph will appear. So for this, we have the data set into the GUI. So you cannot change the data, but you can see how the PV diagram for a certain process. So here, there's a click, isobaric, and then you can also see for isoporic. Okay, next section is the calculation of work. So first one is isothermal. So for isothermal, they have their own equation for work. Alright, where we already set it in the push button here and link it via handle, and the edit text here we are using set app, where the push button can get the data from the edit text here and appear on the space down here. So for example, where you have 6 meter cubic for initial volume, and then you have also 8 meter cubic for the final volume. So noted that the unit here are already set for the equation for work here. So you have to make sure that before you key in the input, you have to make sure the unit you use is in the SI unit. So you click work, and then you can see there's the result down here. And then same goes for isobaric. For example, you have the same value. And then you click work, and then here. So you can see there's a difference because the equation for each of the process is different. And you can also reset the data and repeat the same thing. So the last section is for unit conversion. So for example, maybe you have different unit before you want to use the work process here. So you can convert your current unit before you can use it in the work equation here. So here we are using if function, where you can repeat the same thing after you have done with your current data. So in push button, we already set a few units that you can choose. It is kinda limited, but this one is the common unit that you might find everywhere. Problem solving question. So for example, you have liter, and then you just have to put your current data. For example, you have 67 liter, and then okay, you already have it in SI unit. Okay, so same goes for pressure parameter. So you have in Tor, for example, you also put in the same thing, and then the result will appear in Pascal unit.
So, in conclusion, we can say that GUI is known for its ability to develop a quick linear platform, because why we insert the input that we have and a result can be generated through the commands that we already set in the GUI. Next, we also provide a brief description for the three main processes involved in first law of thermodynamics, which are isocoric, isobaric, and isothermal. And also in our GUI, we have several command, which is switch or switch case, where we
include in the pop-up menu to prompt the graph. And then also else if command. So we use it in unit conversion purpose, where we can choose what kind of unit that we want to convert it into SI unit. And next is user input. So user can input their data in the GUI and calculate the work for isothermal and isobaric process. And lastly, we also have a mathematical solving code, which is we use it to calculate work and also find the value for any parameter, and using the gas law equation. So several recommendations that we can add to improve further our GUI is first, an image of a full PV diagram portraying all processes of the three processes in one graph could actually help users to gain their attention by viewing at the first glance. And second, if there are a function that could provide user to generate a graph by input the data that they have, it will be a very good overview for the user to be exposed of a particular process. And third, we can also might add a clear and concise display of unit conversion from the metric unit to the SI unit, where user can actually see on how the unit is converted to get the unit in SI version. So this is all from group 2. Thank you for watching. Have a nice day.